Okay, finally we're going to determine what the pH is in our sample titration after the addition of 25 milliliters of the 10th molar HCl. Now, we previously determined that we got to our equivalence point for this titration after the addition of 20 milliliters of the solution, which means we are 5 milliliters beyond the endpoint. So in this case, the solution pH is going to be pretty much dominated by just the excess hydronium that there is. So the way to tackle this is to figure out, first of all, what the excess hydronium is. So remember that for at the titration equivalence point, that the amount of acid and the amount of base were equivalent. So we knew that we had two millimoles of the base trimethylamine. Let's see, so for the moles of acid, that's how much base we had. So remember, concentration times volume gives you an amount. So we had .025 liters of the acid. And that concentration is a 10th mole per liter. So this means at this point we have added 2.5 times 10 to the negative 3, or 2.5 millimoles of hydronium, and which means that we have an excess 5 times 10 to the negative 4, or half millimole of the hydronium floating around in there, and that's going to determine the solution pH. So really all you need to do now is figure out that you've got five times 10 to the negative 4 moles of hydronium, and don't forget to calculate the total solution volume, which in this case is going to be the original 20 milliliters plus the added 25 milliliters for a total of 45 milliliters, or 0.4 liters. So that gives us a hydronium concentration of about 1.11 times 10 to the negative 4 molar. I'm sorry, not negative 4, negative 2. And so the pH is simply going to be the negative base 10 log of that. And that's going to clock in at 1.95, which is a very low pH, which is exactly what you would expect for this titration, because at this point you just have a lot of excess acid. And I should say that you might expect the trimethylammonium that was the product of this titration to also create some hydronium, but the amount that it makes is insignificant compared to the excess hydrochloric acid, so you can kind of ignore that at this point. And that's the problem.